I think we can start. Thank you all for joining. Just to ask one last time, can you hear me? Renee, can you hear me?
Yeah, absolutely.
Perfect. So thank you all for joining. My name is Atiya. Unfortunately, my camera is I couldn't get it on, but you have my picture there. I am a production geologist at PDO, and I'll be with you during this session, inshallah. So just before we start, allow me to introduce René. René is a renowned survey engineer, brings over 30 years of expertise in the field of geodesy, with 20 invaluable years at Leica Geosystems in Switzerland, where he specialized in high precision survey technologies for permanent monitoring. Driven by his passion for innovation and commitment to sustainable development, René founded Happy Monitoring in 2019. This cutting-edge GNSS-based solution aims for global implementation, showcasing his ambition to transform monitoring practice across various sectors. Under his leadership, Happy Monitoring is dedicated to providing accurate and reliable data, essential for critical decision making worldwide. Thank you so much for joining us, Renee, and please go ahead. The mic is yours.
Yeah, I think Nadi now begins.
So first, wait, I open my camera. So now I am the Roya International founder of this company. We are the reseller in Muscat for Happy Monitoring that I know more than 5 years already. So we are going to start first with an agenda. Please, can you go for the next slide, please? Yes, so first we are going to explain you why monitoring is so tricky and very important for the real-time data that we need to prevent potential issue and accident for the future. Then we are going to see what is the new area of monitoring that Mr. Schnider developed in the last 5 years. He's the founder of the application and the algorithm, and he will explain you exactly what is the real time of area of monitoring. Then about after the, let's say the why and the what, we are going to show you how is it a real-time monitoring. That means you have all accuracy and all measurement directly managed by yourself to avoid accident and to make prevention. At the end, we are going to show you some cases worldwide where Happy Monitor is already implemented, from Europe to Hong Kong to Asia to Indonesia. And just that you know, we started already in Oman, in Muscat, for a specific project. You can go to the next slide, please. So why monitoring? The monitoring is something very important in the new area of geoinformation. As you can see, maybe the Oman people who are joining us in this webinar, they recognize Ibri, the largest landslide that happened last year. We had some problem with some people, and even we are very sad to lost some people there. Ajra mountain has also landslide, but there are currently landslide in Oman, like everywhere actually in the world. It's also linked with climate change, urbanization that increase this risk of landslide. But landslide is not only the why we use monitoring. It's also for the construction, for any infrastructure that we build. I'm talking about airport, port, breakwaters, mine, dams, motorways. Everything in the world can move now with the prediction of the high level of urban planning. So when we go further in the next slide, next slide, please. What we are talking about is a really keyword application. So urban planning, as you know, we have a lot of plannings and urbanization in Muscat, a high crisis of level of urbanization. Disaster preparedness is implemented early warning system for natural disasters that we are talking about landslide. The last one very important was in Switzerland. I don't know if you saw on the social media, but we had the floods very important in Switzerland. Environmental protection, monitoring environmental changes and impact. And of course, the last one that we are talking very often is about energy efficiency, optimize resources used to reduce environmental footprint. Because when you monitor something that's happening in your building, which is moving, and then you make a monitoring and you can help the civil engineer to solve your problem, you are going to solve not only people, but you solve as well financial issue. Now I give the floor to René.
Okay. Hello, everybody. It's a pleasure and an honor to be here. I like to introduce my monitoring systems. And for beginning, I make a little bit of technical issue, and then we go directly to the examples. And then the end, I'm here for questions to answer you what we can do, how we can help you. Can we go to the next slide? The conventional methods of geodetical monitoring that are normal, the manual measurements, or you go every 6 months, measure the points. That is a monitoring that is not so expensive, but you have no information about what's happening the whole time on the points. The automatic monitoring, when I began, was 99% with total stations. They are very precise, but they have the problem that they work in with an optical system. That means when it's raining, snow, fog, the system doesn't work. And so we have begun to work with GPS systems. GPS systems, the big advantage of these systems is that they have no influence about weather conditions. But in the past, the precision of GNSS monitoring was in about 1 to 2 centimeters. Especially the height was not so good. So this system was only for very big areas to make monitoring. We can go to the next slide. That is clear that in the monitoring world, there is not only geodetical monitoring, there are also the geotechnical sensors, like crack meters, inclinometers, laser rangefinders, photogrammetry scanners. In the moment you can insert data. You have a lot of different sensors that can give you information about what happens on the ground. Can we go to the next slide? When we talk about real-time monitoring, it's something to understand when I talk, and you will see results from measurements, and we are nearby 1 to 2 millimeter of precision. How is this possible when 5 years ago you achieve 1 to 2 centimeters? That have a technical issue. First of all, the constellations. We have begun in the 90s with the American GPS system. Then is 2002 is coming Russia with GLONASS. Then Galileo from Europe. And the last was Chinese Beidou. Now, when you have worked with GNSS systems, the normal way you use GNSS systems from the big brands like Leica, Trimble, Topcon, you have a solution that is based on GPS. That means the first constellation that we'll use is GPS. Without GPS, no measurement. The other systems are nice to have, but in the basics is a solution by GPS. In my analysis that I make with the different constellations, we have now the situation that the best system in the moment is Galileo. And the best system in height at the moment is Beidou. The older satellites from GPS and GLONASS are not so powerful. So we have developed on our sensors a firmware that it's not based on GPS. This system uses the best constellation that in the moment is available. I can make you an example. When you put the sensor outside in Oman, and you measure the signal power, how you receive a satellite. You can measure that the GPS satellite is arriving by 50 to 70 watt input power. GLONASS the same. Galileo and Beidou, 1900 watt. That means when you are based on GPS, your precision will, under difficult conditions, never be the same that you have with Galileo and Beidou, like basic systems. That is half of the secret why we are so precise, because we have changed how we use the different technologies that are available now in this moment. Can we go to the next slide? The system is very simple. You have a fixed station on a fixed point. You have the moving stations on the object, landslide, bridge, what you like. We can go up to 20 kilometers of distance. That is important when we are in a big area where we have, for example, subsidence problems. I will show you later the problem that we have is in Jakarta, Indonesia, where the whole city is going down. We need internet to make the communication on the portal. Without internet, we can't measure. We measure in all weather conditions. That can be heavy rainfall, fog, it's no influence. Here in Switzerland, we have sometimes the problems that we have heavy snowfalls, snowstorms, that influence quite nothing on the quality of the results. The sensors, the new technology is that we use only in about 3 watt of power. That means a small solar panel is it's okay to give power to the sensor. Can we go to the next slide? Now, how it works. That is, I think, who is interested more, I can explain later more detailed how it works. We have the sensors outside in the field, and they transmit every 5 seconds a coordinate. No raw data. When someone goes to the university, they talk about post-processing raw data. We don't do that. We make all with RTK coordinates. These coordinates are stored in a data server, and the calculation is by an algorithm that is developed by me. It's a combination of artificial intelligence and statistic models. You can imagine in a day, with 5 seconds, 5-second data rate, we are arriving in about 18,000 coordinates. And with these coordinates, we make statistic models that can decide what are good measurements, bad measurements, and when a measurement is good, how good is it? So we can, on the high quality data rate, we can go down to millimeter precision with this system. The next slide. That is the requirements: fast power, minimum 12 volt, solar power of 230, minimum 3G coverage. I must see the sky because I work with the satellites. No underground, underwater measurements are possible. And I need a specialist that gives me the information where is a fixed point, where the region is not sliding. So that is something that we can't decide from Switzerland. Can we go to the next slide? What is our technology? That is that now in this moment we use SoC sensors. That is the newest technology based on a chip. That means we have very high data quality, and now we have also tilt sensors inside. These sensors can measure not only movement in 3 dimensions, they can also measure inclinations. So you have in reality 5 values on the same sensor. That is very important, for example, when you have a bridge or a wall, you don't see only that the bridge is moving, you see also that the bridge have a different inclination, like a tilt sensor. Okay, next slide. Okay, so I think we can go to the examples. I'll share now my screen. Just a moment. For the first, we are now on our online portal. That means every project that you make, you have an access to a portal where you can see your data, your results. In this portal, we make also alarm systems. When we have alarm values that you give us, you will receive emails, WhatsApp messages, and in some cases, we go on directly on alarm systems on outside. I think we begin now with something that is very tricky, that is the Hong Kong airport. That is a project that we have now more than 8 months. Tricky here. I can show you. The new Hong Kong airport is an artificial island. Here is a part of an existing island that then is artificial. This island was built new. That is the fuel storage of the airport. And now this island have the authority like to know this island goes down or not, have subsidence problems. Now, the problem here is that we have the runway from the airport that goes directly to the sensors. On an airport, you have very powerful radio stations that guide the airplanes. And that is, for example, on this island, it was 3 different companies that make tests to measure, and Happy Monitoring was the only one that can measure here. Because we don't need raw data, we can go directly on the RTK coordinates. I can show you one point, for example, rower 5, because he is really near to the sea. Perhaps someone from you have made the experience that GPS near to the sea is very difficult because we have refraction from the waves from the sea. And show you the results. You can see here that is 1 centimeter. I can show you only the height, because here is height monitoring. You see that when we began to measure, after 1 month, the island goes down. Was normal, we expected that, but then it begins to come up, then goes down, up, down, and now it's quite stable at the end. In the beginning, our customer said that can be a problem of the precision of the system. But then we have analyzed also the weather data. And in this case, every time when the island comes up, we have heavy rainfalls. You can see that in about 12 to 24 hours after heavy rainfalls, the island come up this point. And that was for the geologists in this case, a new information that before nobody knows about that this island, when we have heavy rainfall, can also lift up, not only go down. So that in the future, to stabilize the situation, they have much more information what they have to do to make the situation safe on this airport. We go to the next project. That is railway. We have the first time in Germany, the sensors on the traverse from the railway. I can show you fast the picture. The sensor is here on the traverse. And this sensor can measure not only displacements, also inclination of the traverse. So you can see when we go on the online page, we have the information about the points. I can choose a point, and you can see, for example, here, what's happening on the height. It's quite stable. That is every 2 hours we have a train here, so we have daily informations about what's happening on the track. That is also together with an alarm system. That means when we have more than 2 centimeters, the signal for the train goes on red and the train don't pass. What we have here also, we have 1 point on the traverse, and we have more the information what's happened on the traverse of the inclination of the rails. That is very important when you make high-speed trains. That is the inclination of the track must be really, really precise. Then another application. That is, for example, something that is very new, but Friday in Switzerland, they called me. We have a problem that the main road in the mountains begins to slide. You can see here, that is the road, and here we have the railway. That is the only way to go in this valley. This road is not for cars. So they are really heavy danger, because when the slide is coming, we will have not only the road, only the railway is going all down. For this case, we have now installed a high-speed monitoring, where we have, in this case, every minute a result. You can see the noise on this data is about ±1 centimeter, but this information is to block the road, to block the train in 1 minute. When the landslide is coming, that immediately they block all the situation there. And we have an information also about the inclination. So when the slide is coming, the sensor falls down, we have a double check before we must block the road. Not we have a false alarm, because that is really not a good situation. So we have a full control with high precision measurements, but also very fast measurement to prevent that when the slide is coming, that the cars are blocked immediately on the road and the trains also. The next is a bridge monitoring that we have made in Austria. That is interesting because the professor here from the University of Innsbruck in Austria, we have begun to make this measurement 1 year before the building site begins. Now is here a new bridge. And what was the idea of this monitoring? We have to learn how this bridge is moving on the normal conditions. It's an old bridge, it's in about 70 years. And with this information, they have begun the building site. And we know how the bridge is moving normally, and we can detect when the building site is giving some bigger errors on the existing bridge. Then we can block the building site. That is for monitoring generally. It's better to begin before the construction site begins. So we have the information, what is the normal movement in this region, and then we can see what is the effect of the building site on the old situation. That was here very important because normally when we begin to monitor when the building site is there, we have every 2 days an alarm because the alarm values are too low. This bridge have movements from 2 centimeters to 2.5 centimeters under normal conditions. No critical values. And last but not least is perhaps for us the most difficult monitoring under an aspect of distance. That is in Jakarta. Surely you have heard about that we have city subsidence problems in Jakarta. Now, for us, the problem here is that the whole city goes down. We don't have really fixed points. They are near to the coast side. So we must make very long, this is the fixed point. We go more than 30 kilometers away from the coastline to determine the subsidence of the city in about 2 to 2.5 millimeter of precision in height. And what the government from Indonesia have made, they have built some housing. I can show you. These points, Gedung 00, 50, 100, 200. That is one housing with 4 sensors on the housing. One sensor is directly on the surface. One sensor is on a pillow that is 50 meters in the ground. One sensor is 100 meters in the ground and one sensor is 200 meters in the ground. That is to detect where is the subsidence lying, in which depth we have to search that the city goes down. I will show you only the height because that is really interesting. You can see here, when you go on the last days, the city is coming up, rainy season. It's normal because groundwater is filled up. The point that goes more up is the 00 that is on the surface. A little bit less up goes the point with 150 meters of depth. And the point with 200 meters of depth is quite 4 millimeters, is nothing. So we can see that on this housing, that the critical depth is in about 100 to 150 meters, where we have to search where is the ground, how is the groundwater level in this region. So that's our informations, because it is quite clear that this subsidence is a problem, that the people pumping up groundwater without permit. And so the city goes down. And we have, in the end of this installation, there will be in about 100 sensors in Indonesia, in Jakarta, to check every region to find out where is more water pumping from the groundwater. I think that is, from my side, the examples that I like to show you. And now I'm open for questions. Are some questions?
Atia, is it possible that the people raise their hand, or they can ask directly question by the chat?
Yeah, we just have one who raised, so I'll allow mic now. So we have Muhsin. Muhsin, you can just unmute and ask your question.
Thank you. I'm Muhsin from India. I'm living in Srinagar, Jammu and Kashmir. We have an old town here. named Ranawari. We are reportedly experiencing some subsidences
Yeah.
there.
Mhm.
So how can we monitor these subsidences? Any
Yeah.
suggestions?
That is for subsidence, you have, that is a city that goes down or a region.
Okay.
What is the case of subsidence? In Kashmir, is this a mountain or a city? What object you like to monitor?
Actually, we have a clay type subsurface lithology.
Yeah.
And old houses are
Yeah.
reportedly developing cracks,
Yeah.
sheer cracks along the windows and doors.
Mhm.
So the administration
Yeah.
is in a doubt what to do, what type of
Yeah.
measures to be taken.
Mhm.
So they have referred the case to our department.
Mhm.
We have investigated and our findings have revealed that there are some artificial caves, or we can say pits,
Yeah. Yeah. I understand.
which were used by the porters for extraction of clay and making of articles
Yeah.
in the ancient period. But these caves or pits were not filled properly as a practice of compaction and rolling.
Yeah.
So eventually, after some time, the people make houses over them.
Yeah. I understand.
Yeah. So my question is how to measure subsidence if there there are reportedly cases of subsidences there.
Mhm.
So my question is how to measure that subsidence. Vertical displacement, we can say, not
Yeah.
displacement, vertical settlement with
Yeah.
reference to the surface. We have
Exactly.
a crude method. We can measure that with metrage from the pit to the surface ground, but that's not the right way.
It's not the same problem that we have here in Jakarta, where we
Okay.
have subsidence in the city.
Yeah.
That is, I share my screen.
Yeah, I have seen that.
Yeah, it's not the same problem.
Mhm.
We have here, we have,
It's
for example,
related to the extraction of the groundwater, as
yeah,
you earlier
exactly.
said.
But that
But
can
that's
be
not.
also, we have a problem in Sri Lanka, where the people
Yeah.
have built houses on landslide, and
Yeah.
that are also on the ground, all caves for, I think, carbon. And now the region is unstable. So we put every house as a sensor that we can
Okay.
evacuate the people when it's too dangerous. When you
Yeah.
have a speed up of the slide of the subsidence, the people must go out from the housings because they don't like to leave the house. They will live there, but it's not safe there. So we have sensors. That is the idea. We put sensors on the housings and make an alarm system that when it's too dangerous, the people must go away.
Great.
That is, for example, something that we can do. That is some cases are, I make a monitoring of an object of a house because people live inside. I must look that the people are safe. When it's a huge region, for example, Tehran in Iran, I was there. They have holes under the city. That
Okay.
is from old cultures. They make caves and sometimes a part of the city falls down in the holes. But before
Yeah.
that happens,
Yes. Yeah.
the
That's the
structure
same
goes
case.
down. And so it's the idea is to monitor what is the normal situation. And when we see that begins to go down, then you can say, stop, guys, go out, something happens. That is exactly the job of happy monitoring.
Okay.
Because we can make the height in 2 millimeter precision. It doesn't exist a system that can make an absolute height in 2 millimeter precision on 10 kilometer distance.
Okay.
Only leveling, but that is not the case. You can go every day 10 kilometers leveling. It's not a nice job. Not in Kashmir. It's too hot.
Yeah.
I answered
Thank
your
you.
question.
Yeah, yeah. Thanks.
Thank you. Other questions?
Yeah, so if no one does have a question, I'll go ahead.
Yeah.
So my name is Sarah, and I unfortunately missed the first part of the lecture, and I
Yeah.
tried to look at the website, but I couldn't find the information that I'm looking for. So, like, what type of analysis or what type of tools you are using to collect these data? Like, are you relying on remote sensing, a drone? Like, how you are collecting these data?
The data collection is, we have the GNSS sensors. They work in RTK mode, and they transmit. I can show you, for example, here. I can go on my screen. Here, for example, you can see that are sensors. That are normal GNSS RTK sensors. They're transmitting every 5 seconds coordinates on my server. And then, when I make a calculation, I use this RTK real-time data with an algorithm, a statistic model, to create absolute high precision positions on the Earth. That is how it works. It's a new approach to use GNSS for monitoring. Is that your question?
Yeah, clear. Thank you so much.
And then perhaps we can send you the. We have a technical report from the University of Munich. They make some analysis of algorithm precision, what we can achieve. That is all made by the University of Munich.
Yes, please.
Okay, thank you. Other questions?
I shared on the chat the link of Happy Monitoring Colibri for everybody. This is the sensor that René talked about during the presentation on the slide. So if you need anything, I also put here my email address so that you can send me an email directly. For the people based in Oman, I am the official representative of Al-Roya here of Happy Monitoring in Oman. Yes. To the chat. Any other question?
Thank you very much. It was clear, our presentation.
Apparently, yes, very clear.
When you have in the future question, please contact Nadine, and then we can also see your project, your problem in that. I know sometimes you can't talk public on some projects that you have, so you can contact directly on Nadine.
Yeah, exactly. So Abdullah, Atia, what should we do?
Thank you, René, for the presentation.
Was an honor. Thank you very much.
Atiya, can you hear us, please?
Yes, I think everybody can hear us.
Maybe Atiya has an issue, maybe with the mic. If someone has any question, please write it in the chat box, or you can contact directly to Nadine. She dropped her email there. And if you would like to ask about anything presented today, please go ahead now. Raise your hand. I will allow you to speak with René. It's a chance to talk to him today.
Thank you. Yes.
René, any project started soon with any Gulf countries?
Now we make the installation of the first sensors in Oman.
In Muscat.
Yeah.
In Muscat.
Yeah, that will be installed, I
week.
think, this week.
This week, yes.
Yeah.
Really?
Yeah.
Very interesting, and we hope to see a result very soon.
Yeah.
Oh, yes, for sure.
Yeah,
sure.
we will install. It was planned that perhaps for today I can show you the first installation in Oman.
Yeah, but we are going to have the first connection only, I think, on Sunday, maybe Saturday, during the weekend.
If you would like to share something about the project and it's allowed, maybe you can in few minutes right now, if you would like.
We cannot share the name of the company of the client, but what I can tell you is an important building that everybody knows in Muscat, very famous building. They have some movement on the basement, and they have some evacuation, they need to monitor to improve the basement stability. And there is a
Nadine, cannot hear you. Nadine, do you hear us?
I think it's something with the internet connection.
Yes, I think so.
Yeah.
We got the point. She said they are monitoring the building, right?
Yeah, exactly.
And this is for a safety in something in a shaking or something happen close to that.
Yeah. That is first safety, second understand why this happened. To then I can make some improvements on the construction. Because before you must understand what is the why it makes like this. Because and so we monitor in high precision the movements, and we can say, look, on this corner of the building we have a problem with the foundation. Make something. And for that, they have decided to make permanent monitoring.
René, you mentioned a project in Sri Lanka, I think.
Yeah.
About there's a caving under the houses of the people there, right?
Yeah, there is they told me now there is in about 4,000 houses in on a huge landslide. And these landslides, because on the ground, are old caves. And now the people there, they are not rich people, they don't like to leave the houses. So the government have decided, we make like this. We monitor the houses, and then when something happens, we make the evacuation before someone die. But
I got sorry for interrupting you. I got the point, but I think we have the same situation in Oman. We have Wadi Shab. There are many caves under the area there, and I remember there were studies there by Sultan Qaboos University before. They are surveying the places there to see how the dangerous or how the risk is there between the inside that village.
Exactly.
I don't know the details, but I think it could be the similar situation.
Yeah, that you can find this situation in different countries, especially where you have old cultures. You see, when you go to China, that is really a problem when you make a metro, that you begin to build tunnels, and then you can find one cave after the other. That was in Rome, in Italy, the same. And for example, when you have projects with subways, then IP monitoring is perhaps the best solution to check the surface, that we don't have settlements when you make the building site. And that is always in the moment, the vertical displacement, the settlement, is one of the most dangerous thing. A horizontal displacement, normally I can see because I have cracks in the surface. You are a geologist, so you know that. But a vertical displacement, it's very difficult to give a value to that. But on structures, when you think on the bridge in Italy, in Gene, that is falling down with a lot of deaths, was a vertical displacement. They measured the bridge. There was a monitoring, but only horizontal. And the middle pillow is going down and the bridge is falling down. And nobody see that. For that reason, now we begin now a lot of monitoring of bridges, because the companies fear about the vertical settlements of the structures.
Okay, I got your point. Thank you for the explanation.
You're welcome.
About this technique. Atiyah, do you hear us?
Yeah.
I think Atiyah has an issue.
Okay.
No more question is coming. There was a question, but Nadine answered it in a chat box. Okay, there is a question. Do you have a memory for the device? Is it polythene or removable one?
That is removable.
Yeah, Nadine said an algorithm. Yeah, removable.
Yeah, you can, for example, when you make a monitoring, and after 6 months, 1 year, you see it's not dangerous there. You move the sensor to a new place. That is simply programming from my side. You must say to me, look, I move this sensor on the new place. I will determine the new algorithm and the monitoring begin. But that is normal when we make monitoring, perhaps it's 30 sensors. You begin because you have the idea, here is the problem. And then you see, no, 10 sensors I can give to another place because there is more dangerous.
Yeah, sure.
So it's very, very flexible, the system.
Yeah. You can control it, you can move it as well.
Yeah.
Okay, I think there's a question from Sarah. Sarah?
Yeah,
please,
one last question.
Go ahead.
So do you have a real photos for the real device, like not a digital one?
Yeah.
I just want to, yeah, please.
I can show you. Just a moment. Oops. We use this one in this moment, the Colibri. That is Hawk is for really special applications on long range. This is a very small sensor. It's only 10 of 10 centimeters. The housing is 20 of 20 centimeters. You see, the sensor is totally protected in a housing. You can also fix it with some protection that is not stolen. And here inside, there is the whole intelligence and the SIM card. The sensor automatically, when you give power, he connect to the server and begin to transmit. That is full automatic. The people, they put the sensor outside, they don't know how is the configuration. So you don't need a specialist to put the sensor outside.
Okay, so I know you maybe mentioned this before, but again, I wasn't here. So does this device like send electromagnetic waves or something? Like,
No coordinates, positions. They
okay,
send out positions every 5 seconds.
sure.
Yeah.
That makes
So
sense. Thank you so much.
It's not.
Yeah.
It's not like your question is that we register raw data,
Yeah.
the signal. No, that are the old systems. Old systems work all with they register the signal of the satellites, and then you go in post-processing to calculate. We make directly the position, the coordinate on place. It's the only system in the world that works like this.
So you only need one device for each project. Like, let's say we have a project or we want to monitor like a specific landscape. You
Yeah,
only need one of these devices?
that depends on you. How many
Okay,
points you like to monitor?
sure.
I can monitor with one sensor, 1 point. What can be then when you have a region that you said, this point here I like to know, we need one sensor.
And how big is it?
20 to 20 centimeters.
Sure.
Very small and very lightweight.
Yeah.
The sensor is 400 grams.
All right. Interesting. Thank you so
Yeah.
much. Thanks again.
You're welcome. Other questions? Yes. You have a question, Mr. Zuhair?
Yes, this is Zuhair. Nice to meet you, René, again. And good what kind of presentation of technology. I don't know. Do you hear me or not?
It's very bad. The quality is very bad. It's difficult to understand.
Okay, okay. I speak slowly just to try to manage that. So my the network problem.
Ah.
So nice to have you here again. And
you.
good to have a kind of presentation of new. I will say new approach of technology. This is very good.
Thank you very much.
I have question here. My question is, can I monitor the health of the instrument? Can I make any kind of diagnosis of the instrument is working, functioning well or not from remotely or internet or
Yeah.
purpose?
The whole system is cloud-based. For example, you can remote control everything. You can make configurations on the sensor by remote. Because you must see, I'm in Switzerland, and I have monitoring systems in Hong Kong, in Indonesia, in the whole world. And I make all the firmware updates, all what is to check on the sensors, I make from here. We installed in every country's special servers for cloud control, that we have full remote control on the whole system. Because it's not possible to go every time that we have a problem. I go to Hong Kong, for example. So I can check all from here.
Okay.
That is the same for you when we make the installation in Oman. I'm here in Switzerland, but I can make the full configuration from here.
Okay, that's perfect. But for the health, is it functioning well or some defect or something like that? Can I detect it from far away?
I don't understand that.
Okay. You
I
have a
don't know.
system installed in Oman. You have system installed in Oman. Okay.
Yeah.
Then how I can make sure this instrument is functioning well, you know, in good condition. The health
Yeah.
is good. Yes. Is it any way to make some kind of diagnosis?
That's excuse me.
Zweri, the
Someone have
question is,
understand?
yeah,
Yeah.
no, I did not understand. Zweri, you need to repeat, but close to the microphone, please.
Okay. I think I have a bit of bad connection. I think of my phone. Let me write the question in the chat. Okay.
Oh yeah.
Yes, please,
Can you write it?
please
That is
write in the
better.
chat. Please write
Okay.
in the chat.
Yeah, so I can give you really the right answer.
Okay.
Zweri is writing the question.
I see. Yeah.
He asked, how can we make the instrument properly sure?
Yeah, that is controlled by the servers. When you have a problem on a sensor, it's not transmitting, no power, or something is interrupted, immediately you receive a message. We check every time, every 5 seconds, the health of the sensor. When the sensor is stolen or falling down in a landslide, we know that immediately. Yeah. Yeah, we need that because sometimes it's really dangerous what we make, where we make the monitoring. So we must be sure that the sensor is 100% perfect. Know that we give wrong results and you make an evacuation. That is not good.
Yeah,
Yes, exactly. Exactly. Like this.
perfect. Thank you. Thank you, René. Thank you.
You're welcome.
I think there are no more questions. Thank you, Zuhair and the other. It was a very interesting question and discussion. Thank you, René. Thank you, Nadine. And Atiya is sending here. He has an issue with the microphone. But on behalf of Atiya and GSO committee, I would like to thank who will attend today. And we hope to see you again with other webinar, inshallah. Please don't forget to take the email of Nadine and ask here if you have any question.
Okay,
Thank you,
perfect.
René. And
Thank you.
we
Greetings from Switzerland.
see you again within
Yeah.
another.
Okay, thank you. Bye-bye.
You all. Bye-bye.